So this should be your second day of learning 8.6. You should have already watched part 1. And now we're going to look at more rational equations, and this time the denominators are not going to be monomials. So I don't know if it makes it easier or harder, but it's different. So we're looking on that same set of notes. This is on the back side if you printed it out, or page 2. And number 5, 8.6 day 2, just says solve the equation. Remember to check for extraneous solutions. So when I look here, I want to go through the same steps as I did on the previous lesson. My excluded values are very important to me. Because if I do all this work and I forget to call something extraneous, I'm going to be real mad. So when I look at my denominators, b minus 2 shows up again. B minus 2, the denominator cannot be a 0. So if you were to add 2 over, that tells me b cannot come out to a 2. That would be excluded or extraneous. So after all this work, if we find out we got that, we're going to have to cross it off. Okay, the other thing to think about would be your LCM. So your denominators, I have a b minus 2, and I have a 1, which is not exciting. And then I have another b minus 2. So it turns out there's a common b minus 2 between two of the fractions. That just means it's its common multiple, therefore the c in the LCM. So just like on the previous lesson, and I know this is annoying, I'm going to rewrite the whole equation spaced out, and I'm going to multiply by the b minus 2, the LCM, over 1, and I'm going to distribute that into each term. Okay, so again, I know this feels like it's a lot of writing. It is, but trust me, it's going to make it better. So the original problem, I'm just going to space it out at first. 1 over b minus 2 plus, leave some space here. I got a 4 over 1 equals, leave some space here, and then a 6 over b minus 2. Now, what I'm going to do is I'm going to put my factors in parentheses. It just helps me. So in front of each of these terms, I'm going to throw the b minus 2 over 1. Again, I'm going to use parentheses. B's and 6's look the same in Abruzzo land. Sorry. Okay, here comes these simplification bubbles, and I think this makes all the difference. If you were to bubble in, box in, do something with each of these multiplication problems, this is a lot easier to look at. Now, you know my theory on colors, guys, right? Math is better in colors. So if you're using just straight up pencil, at least break out like a crayon, a highlighter, anything to do some part of this in color. It really is going to help. All right, it's time to cancel. Oops, again, still can't spell. Okay, this first multiplication bubble, they're going to simplify down because the b minus 2's will cancel. Nothing cancels here. And then over here, the b minus 2's will cancel. Remember, your job in this step is to knock out the denominators. There should only be 1's left, which means we don't have to write them out. And we do have that. So this first fraction, 1 over 1 doesn't disappear. It reduces down to a 1. Don't screw that part up. That's usually where kids mess up here. Here, nothing canceled, but that doesn't mean we can't simplify. So you've got this b minus 2 times 4, which obviously we're going to need to distribute and multiply that together. I'm not ready to do that yet, though. And then equal sign, and then here, 6 over 1, better known as a 6. All right, now I will distribute. And then I'm looking at the nature of this question, and I'm seeing a linear equation. So I just get to solve it like a Algebra 1 question. So this is 4b minus 8 equals 6. Don't forget we got the 1 over here. You're going to want to bring everything to the opposite side. So b's on one side, constants on the other. You might want to start by combining your 1 and negative 8 here, though. So we got 4b minus 7 equals 6. And finally, we can move the terms around. All right, so adding 7. My pen is delayed. This is not a good sign. All right, 4b equals 13. So b equals 13 over 4. And before I get all excited about the question, I got to make sure that that wasn't my one thing I couldn't have. The one answer I couldn't have was 2. I didn't get 2. So this... Okay, pen, any day now. That's my answer. All right. So, just same idea. Nature of the question's a little different. Today you're going to see some denominators like so that are a little more elaborate. They're not monomials anymore. Factoring. Okay, so that yellow reference card that's put on your plans for this week again, the very first step in solving rational equations, it says to look at your denominators and factor if necessary. So when I look at my denominators here, we got some factoring, kids. So x plus 6 does not factor. But this guy does. There's a common x that you could factor out. So we're going to rewrite this as x times x plus 6. Remember, it's really important for common denominators to factor them so you can see their individual pieces. All right, so again, this denominator, we're going to write it in its factored form. We have x times x plus 6. So I want to start this off the same way I did some previous questions. I want to look for excluded values. My excluded values would be my denominators coming out to 0 because we know that's a problem, right? So my denominators, x plus 6 is a portion of all three of them. So here's the idea. The x and the x plus 6 can't be 0. So x can't be 0 and x plus 6 can't be 0. Well, it's done. It's solved. This one you'd have to subtract the 6 over. Come on, pen. All right, x cannot be negative 6. So that tells me that later on, when we get to the end of this question, if I get 0 or negative 6, I'm going to have to cross them off, and they're going to be extraneous. All right, so my LCM would be my next idea. And I look through my denominators, and I see an x plus 6 that shows up a bunch, but it's just one x plus 6. And then I also see a term of x. So that is my LCM. So the excluded value, the denominators, the common denominator, the LCM, they all kind of go together. They're all connected, right? But notice my LCM I'm writing in factored form. So again, I know you don't want to do this, but we're going to. We're going to write this out in this very expanded way. It's going to seem like overkill, guys, but it's so worth it. All right, so leave some space, put parentheses around your factors, and write out your original problem. And of course, write it in factored form. So this next term, leave some space, and then write the 1 over x times x plus 6 in that form. Oh, pen, hang with me, buddy. Alright, then leave some space again. My pen dies on me, we're all in trouble. So here's the original problem, but with factored denominators. And then I'm going to place that LCM over 1 in front of each of the terms. And you know what comes next? Oops. X times x plus 6 over 1. Next comes my little blue bubbles. Okay. You know, I yelled at my kids a minute ago, and they're awfully quiet now. That's either very good news or very bad news. I guess we'll find out in a minute when they start screaming. Bubbles are getting a little weird. Alright, it's time to cancel. So we're going to have some canceling in all three fractions, thank goodness, because I need to knock out all my denominators. Alright, for instance, this bubble right here, the x plus 6s are gone. In this bubble, the x and the x plus 6 are gone. And then same thing here, x and x plus 6 gone. So here's what we have left. In this first fraction, we have an x times a 6. So y'all have a 6x. Why did I make that green? I don't know. I'll put the x in green. Then you can see where it came from, right? Now don't lose the fact that you have a subtraction sign right here. Mine got kind of crossed off. And then again, 1 over 1 doesn't just magically disappear. It's still a 1. Equals, now over here, I think all we have is a 4. Oh my goodness, guys, this became really easy all of a sudden. It's a linear equation, right? We're going to solve it. I'm going to add 1 to both sides. I'm like praying that my tablet behaves enough to finish this lesson. We're going to divide by 6 on both sides. And you're going to get 5 over 6, the fraction 5/6, or the decimal equivalent. I don't know why I keep going with bubbles. Clearly they're not my thing today. Remember, 2 answers I can't have. I can't have x equals 0 and I can't have x equals negative 6. I didn't get either of those answers, which means I get to keep my answer. I know what you're thinking. You're like, she has yet to have a problem where she's not kept her answer. I think that might continue on for our notes today. I don't think I put one on here where the excluded value shows up, but I can't promise it won't happen on your homework or on your quiz later in the week. So please do make a genuine effort to look for excluded values at the beginning and at the end of the problem. Speaking of excluded values, our denominator here is x plus 5, which means x plus 5 cannot come out to 0. So the one thing you can't have here is x can't be negative 5. So keep that in mind when we get to the answer. Our LCM is a listing of our denominators that we need to knock out, and our denominators are frankly pretty lame. You've just got an x plus 5. Okay, for this next question, I usually in class I would take a shortcut, and I would show you what it looks like to do the work without writing everything out. So I'm going to do it on this one, and probably not on the next one, and you'll see why later. So if I was to distribute this x plus 5 into each of the fractions, and this one gets a little weird because the x and the minus 2 are technically two different fractions, but we'll talk about that in a minute. Instead of writing down everything, I'm only going to write down what doesn't cancel. So this first fraction, the x plus 5s would end up canceling each other out. So I'm only going to write down the 6. And then in this next fraction, again, the x plus 5 would end up canceling out with the other x plus 5. So I'm just going to write the x squared minus 2x minus 3. Now that was a little dangerous of me, because when you have a bunch of stuff in a numerator like that, sometimes you have a multiplier in front that you have to distribute, or even a subtraction sign that you have to distribute. So just be careful. I shouldn't have done that probably. All right, now after the equal sign, this is where there's no more denominators, right? You just have like over 1 over 1. So you do have to multiply the x times the x plus 5 and the negative 2 times the x plus 5. So I'm going to write it out just like I worded it just now. So x times the x plus 5, and then a minus 2 times the x plus 5. And I just want to point something out to you. If I would have multiplied the term x minus 2 times x plus 5 and thought of it as a foiling problem, it's the same thing. Like, foiling is distribution. It's exactly what we're doing now in our work. So if you're like, why didn't she write it as a foiling problem? It's because it's the same thing. It's going to work out great. All right, so left side, got a couple of things to collect, and that's it. So x squared minus 2x, I'm going to bring together this 6 and negative 3. And I'm going to call that plus 3. Come on, pen. You got this. Here, I need to distribute. And then we'll have to collect like terms also. So we have an x squared plus a 5x. And then we have a minus 2x and a minus 10, which is the same set of terms you would have got on the foiling question. Okay. So at first, I'm like, oh man, I got a quadratic. I got to bring everything equal, like to one side so it says equals 0. True, most of the time. The difference here, though, is that your quadratic terms are going to end up canceling each other out. Like if you subtracted x squared over here, they'd be gone. So you actually don't have a quadratic, you have a linear. All right, I'm going to collect all my x's together on this side. This is now a 3x minus 10. I'm getting really silly with my colors today, guys. Sorry about that. I'm going to bring the x's to the right side. So I'm going to add the 2x over yonder. And since I'm bringing x's to the right, I'm going to bring constants to the left. Should pay more attention to what I'm doing. I feel like I'm goofing off. All right, 13 equals 5x. And dividing both sides by 5, you get the fraction 13 over 5. Lovely. It wasn't my excluded value, so I get to keep it. So that's what it looks like when you take a shortcut. I don't suggest you guys take a shortcut right now. I feel like the benefit does not outweigh the many, many risks that you encounter when you take a shortcut. It's just my thought. All right, let's take a look at these denominators. We've got an x plus 2. We've got an x plus 2, so that's common. Then we got this guy. Well, y'all, this factors. In fact, I bet it has an x plus 2 when you factor it. This factors into, let's see, x plus 2 times x minus 5. So that's my new denominator. Now that I can see it in terms of its pieces, I can answer all these next questions pretty quickly. For instance, my first question I'm going to be asked is, what are your excluded values? Well, you can't have, what, -2 and +5, right? Because x plus 2 can't be 0, and x minus 5 can't be 0. So that means I can't have, x can't be -2, and x, ooh, that's ugly, x can't be 5. So keep that in mind when I get to the end of this question. If I get either one of those answers, I'm going to have to cross it off. Now, in the same thought, what is your LCM? Well, it's that. It's the x plus 2 that I need to get rid of and the x minus 5 that I need to get rid of. And you know what? I think on this question I will take my shortcut. Might be dangerous, but I'm going to try it, okay? So the LCM, get rid of an x plus 2 and get rid of an x minus 5. Okay, first fraction. So this time, instead of writing everything out, I'm only going to write things that cancel. That don't cancel. So the x plus 2's are going to cancel out, right? So we have this x minus 5 times the x minus 4. I'm going to write that down because that didn't cancel. The x minus 5 has to get multiplied into the x minus 4. Notice what I did there with parentheses. All right. I write down the plus sign. And then in this next fraction, this LCM would have been distributed to that guy as well. Oh my gosh, making it ugly. The x plus 2's would cancel again. So that 1, which is kind of silly, but I'm going to write it, that 1 still has to be multiplied by the x minus 5 from the LCM. So I'm writing down what doesn't cancel. This last fraction, which originally looked so gross, is now going to be my favorite fraction of them all. Because when I distribute this LCM into the last fraction, the x plus 2 will cancel and the x minus 5 will cancel. Since they both canceled, the only thing you need to write down, the only thing that didn't cancel, is the x plus 1 that's up in the numerator. Okay? So your job was to knock out all the denominators. You did. Now we got to simplify. So like here, for instance, we got a big old foiling distribution question. Slow is the name of the game here, guys. Usually I tell you to distribute a 1, but that's kind of silly, so I'm just going to rewrite x minus 5 in a minute. So here we have, go slow, you got an x squared, you got a minus 4x, you got a minus 5x, and then you got a plus 20. I'm not going to do anything here other than write down plus x minus 5. And then x plus 1, nothing happened there either. This time I do have a quadratic. So since it's a quadratic, I'm going to need to move everything to one side so it says equals 0. Careful when you do this though. For instance, you've got some like terms here. Maybe we'll start by collecting all these like terms. That might be a good thought. Clean up one side and then start moving across the equation. That's what I say, especially on these complicated ones. So we have x squared. Let's see, that's -9 plus 1, so -8x. And then 20 minus 5 would be a plus 15. But don't forget, you still have the x plus 1 on the other side. And your job is to get everything to one side of the equation. So it says equals 0. All right, subtracting x. And then subtracting 1. Woo, that's ugly. So, almost home for you guys, kinda. X squared minus 9x plus 14. Ooh, can't write now either. Equals 0. We're gonna factor that quadratic. This is like the never-ending problem. This is as hard as it's gonna get. So if you can follow me on this one, then you're in good shape. That would factor to a -7 and a -2. Those would multiply to positive 14, but they would add up to -9 in the middle of the arches. So now that we solve our two factors, I should say, you get x equals 7 and x equals 2. And I almost got real nervous / excited because I went back up here to look at the excluded values and I was like, 2? But it was -2. So the two answers I can't have, -2 and 5. I didn't get either one of those answers, so I get to keep both my answers. This is a case where, again, you have two solutions to your rational equation. Okay, that was it, guys. That was day 2. You are now well equipped to go practice these. This is tricky, but here's the silver lining. We're done. This is it. This is all I had to teach you for Algebra 2, okay? So our job now is to just really get a good grasp of what we've been trying to do these last few weeks and tie up some loose ends. We are almost there, guys. I see May in the horizon. Okay, we're there. All right, good luck.